Hello everyone and welcome to the Sky This Month for January 2022. My name's Paul Martinaitis and I'm taking over from Joe Greeder, who's presented these shows to you for the last 18 months, and he's done a wonderful job and I've got really big shoes to fill. So I hope you enjoy the series of shows that I've got lined up for you this year. So firstly, let me start by wishing everyone a happy new year. I hope you had a nice and restful holiday period. I hope you've managed to stay safe. And let's hope this year brings us some better weather. Last year wasn't the best in terms of observing weather, certainly for us here in South Australia. So let's hope this year brings some more clear skies so we can get those telescopes outside and under dark skies where they truly belong. Okay, so here we can see the sky as it looks early in January at about 10:30 p.m. So remember, this time of year in the southern hemisphere, the sun sets quite late, and we have to wait at least an hour, hour and a half after sunset before it becomes truly dark, when the sun's at least 18 to 20 degrees below the horizon. So we'll begin in the west. So these are the constellations, of course, that will set first. So you can see it's well and truly time to say goodbye to some of our spring favourites, such as Parvo, Grus, of course home of the famous Grus quartet of galaxies, Sculptor, home of some more nice galaxies such as NGC 253 and 55, and even Fornax as well. So if you want to take a last look at some of the objects in these constellations, you will need to do it as early as possible in the month, and also early in the night as well, before they set. Okay, now moving more towards the north, and we can see that it's well and truly summertime now. So the great summer constellations of Orion, Canis Major, and Taurus the Bull are all now very prominent in the sky. And indeed, there's quite a few nice bright stars as well that signify summer as well. Of course, we have Sirius, the brightest star in the sky. It's only about 7 light years from us as well, so it's one of the closest stars. And then in Orion, we of course have Rigel and Betelgeuse, a big red supergiant. And the fascinating thing about Betelgeuse is it's actually so large. It's one of the few stars that they've managed to image. So with very large telescopes, they've been able to produce some images of Betelgeuse, and they've managed to see some dark patches and various features on its surface, which is very interesting. And then below Orion, of course, we can see Aldebaran, another red star in Taurus. So if you're just beginning your journey in astronomy and you're not quite sure what to look at, whatever instrument you got, whether it be binoculars, a small telescope or a large telescope, there's several objects here that are very easy to find. So firstly, the Orion Nebula, which is probably many people's favourites, including mine. So if we just zoom in a little bit on Orion, and you'll see the 3 belt stars in the middle of the constellation. And then if you look above the belt stars, you'll see sort of 3 fainter stars, and the one in the middle will look a bit fuzzy. So that's actually the sword of Orion. So because in the southern hemisphere, the figure of Orion is actually upside down. So his head is here below near Betelgeuse, and Rigel is actually where his feet are. So that sword hangs down from his belt, if you like. So if you point your binoculars or any sort of optical instrument in that region, you will actually see the Orion Nebula, which is a very bright nebula. It's certainly one of the brightest. And the great thing about it is, even under a suburban sky, just with binoculars, you will be able to see some of the nebula. And of course, the darker the sky is, and the larger your telescope, the more detail you'll see in that nebula. Just be aware, of course, that you won't generally see the colour that you can see here in the simulated picture. It'll generally look greyish or greenish. You can see some colour in a larger telescope. So for example, in my 12-inch telescope with a fairly bright eyepiece, I can sometimes see the outer regions, and I can see that salmon pink colour as well. And the rest looks a nice deep green. And if you look in the centre of the Orion Nebula, you should see, maybe not with binoculars, but certainly with a telescope, you'll see 4 stars in the middle. Sometimes a couple more, but you'll see 4 bright ones. And they're called the trapezium. So those stars were actually created in the nebula only a few million years ago. So they're actually quite young by stellar standards. So the Orion Nebula is a great object. I tend to look at it any time it's above the horizon. At least a quick look. It's a great object for anybody. Now, another nice object that you can look at this time of year is the Pleiades. So if you just sort of move away from Orion towards Aldebaran, with your naked eye, you'll see this little tight cluster of stars, and you'll see between 5 and 8 stars, depending on how good your eyesight is, and probably more so how good your sky is. So this is called the Pleiades, or the Seven Sisters. And this is really a binocular object, more so than a telescope, because you need the wide field. So if you point your binoculars towards that, you'll be rewarded with a wonderful cluster. You'll see the 7 brightest stars that you can see with the naked eye, but you'll also see quite a few others as well. And this, again, is quite a young cluster. It's on its first rotation around the galaxy, so it sort of hasn't dispersed yet. And you can see in that simulated image the Orion Nebula, which that bluish reflection nebula surrounding the stars. You generally won't see that with you won't see that with binoculars, and it's quite difficult to see through a telescope as well. You need a nice dark transparent night to see it. But the cluster itself is a really nice sight. And one more object while we're in this vicinity as well, another nice binocular object. If you look at Taurus here, you can see that the constellation forms this V shape. So if you point your binoculars towards the head of that V there, you'll be rewarded with this nice, somewhat triangular looking, very loose cluster, and that's called the Hades. And that's been known, along with the Pleiades, these 2 clusters have been known since ancient times. And again, this is really a binocular object, the Hades, because you need that wide field to really fit the stars in and frame them nicely. If you take a look at a telescope, you'll tend to be zoomed in too much to appreciate the cluster. Okay, so we'll just zoom out a little bit. And here, of course, you can see Canis Major as well. Our deep sky object of the month, Thor's helmet, will be in Canis Major, so we'll return to that a bit later on in the presentation. So we'll now head towards the south of the sky, and you can see there's a lot of really nice southern constellations visible now. Of course, we have the constellations that make up Argo Navis, so Carina, Puppis, Vela, and Pyxis. So there's a lot of nice objects in there, and in fact, Joe Greeder and I are going to do our next Deep Sky Targets show in spring, and we're going to concentrate on these constellations. So you might want to look out for that later on in the year. So here's Dorado. That's got a lot of nice galaxies in that. The key one there would be 1566, a really nice spiral. And there's Horologium, Reticulum, Hydrus, and Chameleon as well, and Volans. So there's a lot of nice objects in there. And Joe and I did a show in December called The Roads Less Travelled, where we went through some of these perhaps less familiar southern constellations. So you might want to go back to that show that we did in December, The Roads Less Travelled, and maybe have a look at some of the targets in there. There's a lot of nice, particularly galaxies in this region, but there's a few planetaries as well. And while we're here, of course, there's the Southern Cross. So the South Celestial Pole, so that's the axis about which the sky appears to rotate. That's about halfway between Acrux, the brightest star here, and Achernar here. So if you draw a line between those stars, about halfway, that's where you'll find the South Celestial Pole. Unlike the Northern Hemisphere, we don't have a nice bright star like Polaris. So we have to kind of estimate where the pole is. Okay, so while we're in this region, of course, the other thing we mustn't miss are the Magellanic Clouds. So we've got the large Magellanic Cloud and also the small Magellanic Cloud. And this is another object where under a dark sky, it will look quite similar to what you see in this simulated image, particularly through binoculars. So when you look at it under a dark sky, you can really appreciate that it is actually a separate galaxy, and you can see the bar and the sort of the irregular arms that protrude off of it. Now, a very nice object in the Large Magellanic Cloud is the Tarantula Nebula. So, and you can even see this in a suburban sky. So if you point your binoculars or telescope towards the LMC, you'll see a bright patch of light off to one side, and that will be the Tarantula Nebula. And that's another really good object to take a look at, particularly if you've got a filter. So if you've got an oxygen-free filter or even an ultra-high contrast filter, put that in, and even under a suburban sky, you'll get a really good view of this nebula. So let's now see what's straight above. So I'll just move up. So we're looking now straight up. There's the zenith there. And we can see the dominant constellation there is Eridanus, the river. So Eridanus starts at Orion towards the north, quite near Rigel actually, and it snakes its way all the way around, bends and twists all the way until we reach Achernar in the south. So it's a very long constellation. In fact, it's the second longest after Hydra. And there's a lot of really nice objects along Eridanus, predominantly galaxies, some really nice galaxies. There are a few open clusters, however, and a few planetary nebula as well, in particular NGC 1535, sometimes known as Cleopatra's Eye. It's a really nice planetary nebula. Okay, so let's take a look at the lunar phases for January 2022 and look at what are some good times to do observing. So you can see the calendar there on the right. I've highlighted in blue the times where the moon, due to its phase and rise and set times, won't interfere significantly with the dark sky. So they're the times of the month, pretty much from the 1st to around the 6th of January, and from the 25th of January through to the end of the month. They're the times that you'll want to set aside for deep sky observing. So looking at things like galaxies, faint open clusters, nebula, and so on. The times in between, from the 7th of January through to about the 24th of January, you'll want to really keep them for lunar observation, double stars, and bright open clusters, and perhaps also the planets. Although, as we'll see, January's not really a great month for planetary observing. So the moon phases you can see listed there. So new moon will be on the 3rd of January. We have first quarter on the 10th. Full moon is on the 18th of January, and the last quarter will be on the 25th. And I've also just listed there the dark sky times. So this is particularly relevant from South Australia. And you can see that the darkness at the beginning of the month begins at around 20 past 10 and ends at around 4:20 in the morning. By the end of the month, the darkness begins a bit earlier at around 10 p.m. and it ends at 4:50. Okay, so let's take a look at the lunar feature for this month. So what we're going to look at this month are some objects around Mare Crisium. Two craters in particular, called Messier, named after the famous comet hunter, Messier and the Messier catalogue, and Proclass as well. And the unique thing about these craters are that they have a particular ray pattern. Now, with craters normally, of course, we could make inferences about the age of them, depending on where they appear, their shape, how much they've deteriorated, and so on. But the interesting thing about these sort of craters is, by looking at the ray patterns, we can also actually infer what direction the object came, the impactor came that produced the crater, and even also the angle of impact, roughly as well. So these craters are found around Mare Crisium. So Mare Crisium itself is quite easy to see. You can certainly see it easily through binoculars, and it's the round mare towards the east limb of the moon, detached from the others. So most of the other mares, such as Tranquillitatis, where Apollo 11 landed, Serenitatis, even Imbrium and so on, they're all kind of connected together in some way. They don't have a separated boundary from the others. But Mare Crisium is kind of unique in the sense that it's separated by its own rim of material. So the first crater we'll look at is Messier. So the Messier craters, they're a pair of craters below Crisium, and they're actually in a sea called Mare Fecunditatis, or the Sea of Fertility. So the photo on the right there shows you roughly what they would appear to look like through a telescope. So to see the structure of these craters, they'd be best observed around 4 or 5 days after new moon, when the terminator is quite close. But if you also observe them when the moon is fuller, first quarter or after, the ray systems, those streams of white material, will become brighter and much easier to see. So if you look at the close-up on the left there of the crater system, a few things are a bit strange about it. Firstly, they're a pair of craters, somewhat oval-shaped, and you can see the red arrow pointing to the left. There's a V-shaped ray coming out from the crater on the left. So the crater on the left is called Messier A. The crater on the right is just Messier. So you've got that V-shaped ray coming from the left-hand crater, Messier A, very obvious in a telescope, particularly as you get towards full moon. And on the right crater, there's rays sort of going vertically, coming out the top and pushing down the bottom as well. So over the years, there's been many bizarre theories, about this pair of craters and the ray system itself. The theories range from they were in the 18th century that they were artificial. In other words, they were created by people living on the moon. As late as the 1960s, some other theories were bandied about, such as Messier A is migrating towards the east, and as it migrates, it leaves a trail of rubble behind. And another bizarre theory was that the impactor entered through Messier, tunnelled underneath, and then it emerged out of Messier A. So, of course, all those theories are not quite right or completely wrong, depending on how you look at it. So what they did in the 1970s, to gain more understanding of how impacts occurred, they actually used a vertical ballistic gun, and they were able to shoot very small projectiles into solid granite, and then at very high energy, about 7-8 kilometres per second, and they were able to then study the dispersion pattern of the debris. And it turned out that as you alter the angle of impact to the surface to about 45 degrees, it didn't make much difference, but then as you got below 45 degrees, the actual debris pattern caused by the impact started to change a lot. And in particular, when it was a very oblique angle, around 15 degrees or less, you got this sort of pattern that you can see there in the diagram at the bottom of the slide. So what happened is there's sort of a forbidden zone or a null zone coming in the direction, forming about 120 degrees in the direction of the impactor, where there were no rays at all. And then in the direction of impact, there was some narrow rays coming out. And then to each side, there was like a butterfly pattern emerging. And if you compare that diagram on the left to the picture of Messier A there, you can see that it's just the opposite way around. So if you were to flip that diagram left to right, you would see that that corresponds very closely to the situation we have here with Messier A. So from that, we can actually infer that the impact direction for Messier A came from the right-hand side, created the first crater, Messier. Hence, you can see that you've got those rays coming out, fanning out top to bottom, and then ricocheted and caused Messier A, and then skidded along and formed those rays going off to the left. So we're now going to take a look at another crater called Proclass, and that's sort of right on the ridge of Mare Crisium. And you can see that this is actually a very similar situation. So again, if you look at this crater towards full moon, it's very bright. In fact, it's one of the brightest craters on the moon, so it really, really shines, just like you can see in that Clementine probe photo there. And you can see again there's this exclusion zone of about 120, 140 degrees where there are no rays, and then you've got all those rays fanning out to the side and forward. So that was a mystery for a long time, until again they did those experiments and they realized that it was simply because that crater was formed from an impactor that came in an oblique direction, in this case from a southwesterly direction. So therefore that's where the exclusion zone is, which is sometimes called Palus Somni, the Marsh of Sleep. And then it came from the southwesterly direction, formed the crater, so you've got the ejectors coming top to bottom and also off towards the right. And indeed, if we look at Mare Crisium itself, to us it's a little bit hard to see its exact geometry because of course it's foreshortened, so it appears oval to us anyway. But if you look at that photo on the bottom there, that's actually a view from the Lunar Reconnaissance Orbiter probe looking above Mare Crisium, and you can see that it's oval shape. It's got quite a oval shape, which again suggests the impactor came from left to right or right to left. And also the debris pattern, which is very hard to see. This is an impact. This is what's called a basin. So basins are the earliest impacts on the moon, formed by extremely large objects. And what happened is when they hit, they created a ring, large concentric rings of material. And the material tended for Crisium concentrate towards the north and the south. So that fact, combined with the fact that it's oval, indicates that it was again created by some sort of very large impactor, in this case coming from a horizontal direction. And while we're here too, just one final note: if you look at that lower crater shown in the photo, that's actually called Picard. So if you're a fan of Star Trek, it's named after Jean Picard. Unfortunately not Captain Picard from Star Trek, but it's still a nice crater to look at. It's the largest, most prominent crater inside Mare Crisium itself. Okay, so let's look at the solar system. So unfortunately, January is not really a great month for looking at the planets. Most of them aren't really ideally positioned. So let's take a look. So firstly, starting with the inferior planets, Mercury and Venus. You can see Mercury is pretty much the only planet that's really well placed. So that's reaching what we call greatest elongation, which means it's 90 degrees. So if you draw an axis between the Earth and the Sun, and then another axis between the Sun and Mercury, when that line gets to 90 degrees, we call that greatest elongation, which means Mercury is the largest distance from the Sun, from our point of view, making it easier to observe. So at this point here, at the moment, early in January, Mercury is a good evening object to observe in the evening. Venus, on the other hand, you can see is moving towards what we call inferior conjunction, which means it's placing itself between us and the Sun, so it's therefore unobservable at the beginning of the month. And you can see that as the month progresses, if we sort of move time forwards towards mid-month, you can see that Mercury, by the end of January, also reaches inferior conjunction and is therefore unobservable. And in fact, we have to wait until February. So if we just wind time on as well. You can see that as we move into February, so we're now moving towards the middle of February, and you can see that both Venus and Mercury re-emerge, if you like, from the Sun and become morning objects. So they've gone from becoming evening objects to becoming morning objects. So let's look at what else we have. So we're just moving back towards the middle of January. So Mars, you can see at the moment, is a morning object. So if you want to take a look at Mars, you'll probably have to get up pretty early, around 3 or 4 a.m. Now, if you're an avid Mars observer like I am, you probably know that Mars comes to opposition every 2 years. It didn't come to opposition last year, so the great news is this year there will be another opposition, I think around December the 8th. So I'm really looking forward to that, and we'll talk a lot more about Mars as that date approaches. For now, you can see that the distance between Mars and Earth is still quite a lot. But if you want to get an early look at Mars, certainly take a look in the morning. Let's now look at the outer planets. So you can see Jupiter and Saturn. Again, they've really passed their optimal observing window. They're really quite early evening objects. So if you want to observe them, take a look at them early in the evening. But as the month progresses, they'll set earlier and earlier. And we really have to wait for them to come around later in the year. So the best times for observing Jupiter and Saturn will be when they come towards opposition later in the year. So Jupiter will be coming into opposition in September, late September, and Saturn in August. So sort of in spring is when these planets will really be at their best. So just looking a bit further out again, we can see Uranus. That's in a reasonable position. So if you want to have a look at Uranus, certainly again fairly early in the evening, and Neptune would be setting very early in the evening as well. Okay, so we're now going to look at the deep sky object for the month. And like I pointed out earlier, there's certainly some nice objects around at the moment. So please don't miss things like the Orion Nebula, even the Eta Carini Nebula in Carina, and so on. But the object I'd like to look at today is NGC 2359 in Canis Major, sometimes known as Four's Helmet. So it's a really nice object. I like it a lot because it's one of these objects that a lot of people have photographed it, but not so many people observe it visually. But it's a very good object to observe visually if you've got a reasonable scope, probably 4 inches and above, and in particular if you've got a nebula filter. It responds very strongly to a nebula filter as well. So this is actually a nebula caused by a Wolf-Rayet star in its centre. So a Wolf-Rayet star is an extremely hot star. In this case, I believe it's about 110,000 Kelvin. It's extremely hot, about 13 times the mass of the Sun. And this is a star that's believed to be towards the end of its life. So this is in a, if you like, a pre-supernova sort of stage. And it's giving off all this radiation and radiating material from it. And due to the pressure of the solar winds coming from it, it interacts with a molecular cloud that's surrounding the star. And that's what causes the nebula that we see. So if you look at that photo, that gives you a good impression of what it looks like through the eyepiece. But of course, through the eyepiece, we won't see colour. We'll just see it as a greenish or greyish looking image. So what you'll be able to see is, you'll be able to see the star in the middle. And then it's surrounded by kind of what looks like a bubble of material, a nice round sort of region of material. And then coming from that round circle are 4 arms. So the 2 horns that you see coming up, which make the horns of Four's helmet, they're certainly the brightest and the longest. And then the 3rd arm, coming sort of in the downwards direction, is the next brightest. And then the 4th arm is quite relatively faint through the eyepiece. But you can certainly make out the shape, most of the shape that you see there in that photograph. The main trick, like I said, is to use a filter, particularly under suburban skies, but even under a dark sky. So one thing I certainly recommend, if you're putting together your observing kit, one of the first accessories that you should buy is some sort of nebula filter, an ultra high contrast filter or an oxygen filter, because it really helps with objects like this. And it brings some objects from invisibility or virtual invisibility to becoming visible. So certainly give this object a look at, and I'll show you where it is in the region of the sky. So it's in Canis Major. The constellation itself, of course, is very easy to find. It's because Sirius is in it, the brightest star in the sky. And I've marked the position of Thor's helmet with a Telrad circle. So that outer circle is 4 degrees. So that kind of gives you an idea of how far away it is, or where it is in relation to the constellation. So it's about, I would say, about 6 to 7 degrees south of Sirius. So thanks everyone for looking at this presentation. I hope you found it informative. Like Joe, I use Stellarium to generate the sky tour and a lot of the sky maps. So certainly if you would like to experiment with that yourself, I would encourage you to do so. It's available for all platforms that you could think of likely to use, so including Linux, Mac, and of course Microsoft Windows as well. Certainly, and it's free. The best thing about it is it doesn't cost you any money. So have a download of it, and it's a really good way of learning the night sky and seeing what's visible at various times throughout the month. And also I'd encourage you to subscribe to the Society's social media channels. We've got our YouTube channel where a lot of the live streams occur, and if you missed the live version, such as, I'll give another plug for Joe and I's The Roads Less Travelled show that we did in December, you'll be able to watch recordings of those shows on YouTube. There's also a Facebook page, Instagram and Twitter as well. So I hope you have an enjoyable and importantly safe month. I hope the weather's conducive to you getting your telescopes out, and enjoy, and I will see you next month for February. Bye for now.